All right, we're looking at section 1.4 on pairs of angles. So these are two pairs of angles we have here, adjacent angles and linear angles. Adjacent angles have two angles in the same plane with a common vertex and a common side. You'll notice in the picture I have here, I've got two angles. I'm going to pull them apart here. I pull them apart, I've got my two angles. When I put them together, they share a side and a vertex. So those two angles are adjacent. They're right next to each other. They share a side, which is the ray, and they share a vertex. So those are adjacent angles. Now, if you look at the picture down on the bottom, those are also adjacent angles because they're right next to each other. They share a side and they share a vertex. But these are special adjacent angles. They're called a linear pair. A linear pair is a pair of adjacent angles whose non-common sides, these would be the non-common sides. The non-common sides are opposite rays. So these adjacent angles create a straight line when you put them right next to each other. And those are a linear pair. When we start looking at angle pairs, we're looking at supplementary angles and complementary angles as well. You'll notice the picture at the top is a linear pair, and the picture at the bottom are adjacent angles, but that's just for those two pictures. Supplementary angles are two angles whose measure sums to 180 degrees. So if in my picture here, the larger angle was, or excuse me, the obtuse angle is say 102 degrees, and the acute angle is 78 degrees, 102 plus 78 is going to be 180 degrees. So those two angles are supplementary. Now, one thing to note, the angles do not have to be adjacent. What I mean by that is, if I have an angle here that's 102 degrees, I have an angle over here that's 78 degrees. Those two angles I just drew are supplementary. Even though they're not right next to each other, all they have to do is add to 180 degrees. They do not need to be right next to each other to be supplementary. Well, on that same note, complementary angles, very similar. Complementary angles are two angles whose measures sum to 90. So two angles where when you add them together, they equal 90 degrees. Their measures do. So again, let's say if I had this one was 78 degrees, the other angle would have to be 12 degrees because 12 plus 78 is 90 degrees. Two angles whose measures sum to 90 degrees. Again, just as before, they do not need to be right next to each other. If I drew an angle over here, that's 12 degrees. These two angles are complementary angles. They're not right next to each other, but 12 and 78 add to 90 degrees. So those two angles are complementary. Okay, supplementary, 180 degrees, complementary, 90 degrees. Let's look at an example. So for this example, I'd like you to name a pair of complementary angles. Let's go ahead, pause, see what you can do. All right, there's only one option here. And if we look, the two angles that sum to 180, or excuse me, sum to 90 degrees, is this angle here and this angle here. Angle TQP is 47 degrees, and angle SQR is 43 degrees. And 47 plus 43 will give you 90 degrees. So remember, you do need two angles to make complementary angles. TQS is just one angle, so it has to be two separate angles that add to 90 degrees. Let's try another one here. Name one pair of supplementary angles. Just take a second, pause, see what you can do. All right, let's see how you did. This one's a little trickier because if you look, there's only three numbers, and if you add any two of them together, you don't get 180. What you have to remember is that this angle right here, angle TQR, is an angle. It's an obtuse angle. So angle TQR, when we look at it, goes from here all the way to there. So angle TQR has the angle measure of 133 degrees. Going with that, to find the supplementary angle that goes with that, we're looking at angle TQP. Angle TQP. Angle TQP has a measure of 47 degrees. 47 plus 133 is going to give us 180 degrees. So there are supplementary angles in there. Don't let Ray QS screw you up. It's still an angle TQR. You could also have said angle SQP and angle SQR would also have worked for that one. Okay. Intersecting lines form two pairs of vertical angles. We're talking about vertical angles here. And vertical angles are always congruent. They always have the same measurement. So I'm going to give you an example in a second. One thing I want to talk about is what they look like. So when we have a pair of intersecting lines, we have something that looks like this. And our vertical angles are going to be on opposite sides of that intersection. So maybe angle 1 and angle 3. Now don't get confused by the wording. Vertical angles are just across from each other. 1 and 3 are horizontal, but we call them vertical angles. One of the reasons for that is because we can always rotate things around. 1 and 3 are now going up and down, so they are vertical. We can do these things because geometry is just in your head. It's very abstract. So 1 and 3 are vertical angles, and 2 and 4 would be vertical angles as well, right across from each other on that intersection. I'm going to erase my picture because I think there's another one that comes up here. Yep, there we go. So in this figure that I pulled up, angle 1 and angle 3 are vertical, and angle 2 and angle 4 are vertical. And again, they're always the same measurement when they're vertical. So angle 2 is the same as angle 4. They're congruent. And angle 3 and angle 1 are congruent as well. So if the measure of angle 1 is 37 degrees, what would be the measure of angle 3? That's right. Measure of angle 3 would also be 37 degrees. Since they are congruent, they are going to have the exact same measurement. 37, 37. Okay, that's it for this section. Good luck.